Right now, at this exact second, there are roughly 20 million shipping containers moving across the world's ocean.
Yeah, which is just a staggering number to try and visualize.
It really is. And inside them is literally everything. I mean, from raw industrial chemicals to the microchips in your car to the very microphone I am speaking into right now.
And the funny thing is, we usually don't give it a second thought,
Yeah.
until something goes wrong.
Right, exactly. Like what happens when one of those massive container ships gets stuck in a canal, or a critical factory suddenly goes dark, or I don't know, a snowstorm completely shuts down a major freight hub?
Well, that's when things get chaotic.
Yeah.
This is an incredibly high-stakes environment. We're talking about the B2B or business-to-business supply chain.
Right.
This isn't about someone buying a sweater online and getting annoyed that it's late. This is about how industries actually survive. It's about how they move massive amounts of capital and physical goods across borders and, how they engineer systems that can actually withstand catastrophic disruptions.
Welcome to the Deep Dive. Our mission for you today is to decode this invisible world.
Yeah, to really look under the hood.
Exactly. We are going to explore the exact stages a complex B2B order goes through and how companies handle the inevitable chaos when things do go wrong.
Which they always do.
Oh, always. Plus, we'll look at the cutting-edge tracking technologies, giving them this sort of godlike view of their inventory. We are specifically looking at how satellite-linked RFID and blockchain work together.
That part is mind-blowing.
Totally. And finally, the crucial metrics, the KPIs companies use to grade their own survival. Okay, let's unpack this. To really understand how businesses track and measure their success, we first have to understand the journey of the order itself.
And in the B2B world, that journey is meticulously planned. I mean, there's a very specific life cycle for every single order.
Right, and the sources break this down pretty specifically, right?
Yeah, it's broken down into 4 distinct stages that encompass 13 specific steps. It forms the absolute skeleton of the entire supply chain.
Okay, rather than just listing out 13 steps for you like a textbook, let's try to ground this in reality.
Good idea.
Let's say a major research hospital in Chicago is ordering a state-of-the-art $500,000 MRI machine, and they're buying it from a specialized manufacturer in Germany.
Oh, that is a perfect high-stakes example. So stage 1 of the cycle is order transmittal.
The origin point.
Exactly. Step 1 is the hospital requesting technical information and getting a formal price quote. Then step 2 is the hospital officially placing that massive order.
Which sounds simple enough. I mean, it's just buying something.
It sounds simple, but the technical accuracy here, getting the exact specifications of the MRI machine correct in the digital system, that dictates the success or failure of the next 11 steps.
Oh, wow. Which I guess brings us to stage 2, right? Order processing.
Yeah.
Now, I was reading through our sources, and this stage encompasses steps 3 through 8. So the order is received and entered into the system. The manufacturer reserves the inventory. They identify a delivery date, they consolidate orders for freight, they plan and build the loads, they route the shipments, and finally, they use a routing guide to select carriers and rates.
That's correct. And it is arguably the most critical phase of the entire operation.
Okay, I actually want to challenge that for a second.
Okay, go for it.
Because looking at that list, steps 3 through 8 are essentially just people sitting at computers. You've got 6 out of 13 steps happening before a single person has even touched the physical product.
Right.
So how is a bunch of digital paperwork more critical than actually, loading this fragile $500,000 machine onto a truck?
What's fascinating here is that stage 2 is where the most complex, invisible logistics happen. This isn't just about moving a box. It is fundamentally about allocating resources and mitigating massive costs before a product ever leaves a shelf.
Okay, explain that.
Well, let's go back to your hospital example. The manufacturer in Germany isn't just shipping one MRI machine to Chicago, right? They are probably shipping dozens of highly sensitive medical devices to various parts of North America that same week.
Oh, right. So they have to figure out the puzzle of getting them all across the ocean efficiently.
Exactly. That's the consolidation and load building step. If they don't consolidate orders efficiently here, they might end up paying for, say, 2 half-empty, specialized climate-controlled cargo containers instead of just one full one.
Which would cost a fortune.
A literal fortune. And then there's the routing guide. That is a strategic set of rules dictating which specific ocean freighters and trucking carriers to use, mostly based on cost, reliability, and the destination.
Right.
If they don't use their routing guide properly, they might select a carrier that charges a massive premium for route to Chicago they don't normally service. Stage 2 is where profit margins are either protected or completely destroyed.
You know, that actually reminds me a bit of a chaotic high-end restaurant kitchen.
Oh, how so?
Well, the waiter taking the order out in the dining room, that's our stage 1 transmittal, right?
Sure.
But back in the kitchen during stage 2 processing, the executive chef doesn't just immediately throw a steak on the grill. They have to reserve the ingredients. They have to figure out which dishes for table 7 can be cooked and carried out together.
Right, which is consolidating and load building.
Exactly. And then they assign the right food runner to take it out, which is the carrier selection. All that mental orchestration happens before anything actually goes on a plate.
That's a really great way to conceptualize it. The chef's strategy ensures the kitchen doesn't collapse during the dinner rush. And in logistics, that digital strategy ensures the company doesn't bleed cash on freight costs.
So the chef has the plan. Now we move to physical reality. Stage 3, order picking and packing.
Right. This is where the digital plan becomes physical action. Step 9. The specific MRI components are actually picked at the depot or the manufacturing center. Then step 10. The specialized vehicles are loaded and the complex international shipping documents are officially created.
And finally, stage 4, order delivery. We cross the finish line.
The part.
So step 11 is receiving and verifying the MRI machine at a hospital in Chicago. Step 12 is the highly technical installation of the product, which I guess is often bundled into these B2B contracts.
Yes, very often for complex machinery.
And step 13, the product is invoiced for payment. The cycle is complete.
And that is the perfect 13-step cycle, the ideal happy path scenario.
But let's be real for a second. The real world completely ignores our perfect 13 steps.
Oh, constantly.
Like, let's say our MRI machine makes it across the ocean, but a massive labor strike shuts down the port in New York right as the ship arrives. Reality hits. So let's talk about what happens when things go sideways.
That is the true test of a distribution network. We call these deviations exceptions.
Exceptions, okay.
Yeah. An exception is literally any event that disrupts that perfect 13-step plan. And when an exception occurs, it requires immediate intervention to keep the supply chain flowing. Which brings us to the concept of expediting.
Right. And I have to admit, I always assumed expediting was just a fancy business word for panic.
Panic.
Yeah. Like, the port is shut down, everyone is freaking out, and executives are just throwing money at the wall, paying whatever it takes to fix the problem fast.
It's a very common misconception, honestly.
Right.
But true expediting isn't panic. It's a pre-calculated contingency.
I calculated.
Yeah. A well-designed supply chain already knows exactly what to do when an exception happens. When that port strike in New York happens, the system doesn't panic. It automatically evaluates the cost of, say, rerouting that cargo ship to a port in Philadelphia and shifting the freight to different carriers.
Oh, wow.
And it weighs that against the massive financial penalty they will incur for missing the hospital's strict installation date.
So it's a mathematical decision, not an emotional one.
Precisely. Managing exceptions effectively using defined expediting protocols is exactly what separates a resilient supply chain from a fragile one. The contingencies are already built into the model.
That actually explains a lot. The panic only happens if you don't have a plan.
Exactly.
But there is a catch here, right? To even know an exception has happened, to know that your MRI machine is stuck on a boat off the coast of New York, you have to actually be able to see the product.
You can't fix what you can't see.
Exactly. Which brings us to our next major topic, the all-seeing eye of inventory traceability and tracking tech.
Visibility is the ultimate currency of modern logistics. Let's start with a foundational piece of this visibility. The Advanced Shipping Notice, or ASN.
Yeah, looking at the sources, it says the ASN provides order visibility, which reduces uncertainty in replenishments by giving the buyer time to prepare for the receipt and plan the deployment of the contents.
Right, so let's stick with our hospital. Receiving a $500,000 MRI machine isn't like getting a pair of shoes left on your porch.
Obviously not.
The hospital needs a specialized rigging crew. They might need to reinforce floors or clear specific hallways so it fits. Without an ASN, the truck just shows up, and the hospital administrator has to scramble to accommodate it.
Pulling resources away from actual patient care.
Exactly.
So an ASN is essentially a highly detailed, legally binding heads-up. It tells the hospital exactly what is arriving, precisely when it will hit the loading dock, and exactly how it is packaged, so they can prep the environment.
It entirely removes the element of surprise.
It smooths out the operational variance, right? Which is a concept we'll get to shortly, I know.
Yes, we will. But to generate that ASN in the first place and to track the goods dynamically in transit, we need physical tracking technology, and we've evolved far past basic barcodes.
Yeah, because in B2B supply chains, especially for high-value goods like this, we are looking at RFID, radio frequency identification.
RFID is a massive leap forward. Because think about it, a traditional barcode requires a person to physically point a scanner at a label.
Which takes time.
Right. It requires a direct line of sight, which is slow and prone to human error. RFID changes the game. The tags emit radio waves, so they can track work in process on the assembly line, monitor packages resting in deep storage, and track them dynamically during transport.
Here's where it gets really interesting, because this isn't just a localized scanner inside a warehouse anymore. The data from these RFID tags can be beamed via cellular networks or even communication satellites directly to a central system.
Yeah, the global reach is incredible.
Right. That means our container holding the MRI machine sitting on a ship in the middle of the Atlantic Ocean is actively pinging its location, its temperature, and its status.
If we connect this to the bigger picture, this level of technology is solving a massive problem of trust and fragmentation.
Fragmentation.
Yeah, think about the journey of that MRI machine. It changes hands from the German manufacturer to a trucking company, to a European port authority, to an ocean freighter, to U.S. Customs, and finally to a domestic rail or trucking network in the States.
And I'm assuming none of those companies share the same internal IT systems.
Not at all. They all have their own private databases.
So they can't talk to each other.
Exactly. In the past, the data was siloed. The ocean freighter knew where the ship was, but the manufacturer and the hospital just had to wait and hope. Now, we use batch processing and, increasingly, blockchain technology.
Okay, I have to admit, I usually roll my eyes when I hear the word blockchain.
A lot of people do.
Yeah, because it's so tied up in cryptocurrency hype and all that. So how does it actually work for a physical supply chain?
Well, in logistics, blockchain acts as a neutral, decentralized digital ledger. Because all those different parties, the trucking company, customs, the ocean freighter, they don't necessarily trust each other to have access to their private internal servers, right?
Makes sense.
So instead, they all write their updates to this one shared blockchain.
Oh, I see. So as the satellite-linked RFID tag pings its location, it automatically updates the shared unchangeable ledger.
Yes. In-transit inventory tracking, down to the specific purchase order or even the scary U, is logged securely. And it can be customized by role, so buyers and suppliers can access this secure data via batch processes or real-time blockchain feeds.
Wow.
Technologies like blockchain and satellite RFID create an indisputable, real-time single source of truth. It entirely removes the whole "where is my stuff?" guesswork.
And more importantly, if an exception occurs, like that port strike we talked about, everyone sees it simultaneously on the blockchain, and those mathematical expediting contingencies can be triggered automatically.
That is the ultimate goal. Complete, actionable visibility.
But man, that level of visibility generates a staggering amount of data.
Mountains of it.
And that leads us to the final piece of the puzzle. With all this sophisticated tracking data securely stored, organizations have to step back and ask themselves, are we actually doing a good job? Like, are we making money?
Which brings us to key performance indicators, or KPIs, the ruthless scoring system of the supply chain.
Based on our sources, there are dozens of ways to keep score, but let's focus on the tension between two main categories.
Okay.
First, we have customer service KPIs. These measure external success. Metrics like the percentage of orders satisfied directly from stock or the percentage of units delivered on time by the original commit date.
Right. And on the flip side of that, you have stockout metrics.
Running out of stuff.
Exactly. Stockouts are a critical failure in B2B logistics. Stockout isn't just a minor inconvenience, like a grocery store being out of your favorite cereal.
Right.
It can literally shut down a customer's entire production line. That's why companies obsessively track the percentage of item stockouts, their fill rates, and the average time it takes to satisfy back orders.
Well, avoiding a stockout seems like the ultimate goal then. I mean, just keep a ton of inventory on hand so you never run out, right?
You can do that, sure. But providing perfect customer service by hoarding inventory is incredibly expensive. It ties up all your capital and physical goods sitting in a warehouse.
Which isn't ideal.
No, not at all. That's why we have distribution efficiency and inventory management KPIs to counterbalance the customer service side.
Okay, let's look at one of the biggest efficiency metrics then. The cash-to-cash cycle. What exactly is that measuring?
The cash-to-cash cycle measures the time between when you pay your suppliers for raw materials and when you finally receive payment from your customers for the finished product.
Oh, wow. Okay, so if a manufacturer pays for the raw metals to build our MRI machine on day 1, but they don't get paid by the hospital until day 90.
You have a 90-day gap where millions of dollars of working capital are trapped inside physical metal.
Mm.
They can't use that cash to pay employees, invest in new tech, or weather a disruption.
That sounds stressful.
Very. So the shorter the cash-to-cash cycle, the healthier the business.
So what does this all mean when we put it together? Because I'm looking at another efficiency metric here, percentage of storage utilization. Let's say I'm a warehouse manager and my storage utilization is at 100%. I mean, I am using every single inch of the warehouse space I pay for. Isn't that peak efficiency? Or does that just mean I'm a hoarder and my customer service KPIs are going to plummet because the warehouse is just too stuffed to actually find and move anything?
This raises an important question, and you've really hit on the core conflict of distribution planning. High efficiency directly competes with customer service.
Interesting.
Think of managing a supply chain like tuning a high-performance race car.
Oh, okay. I like that.
If you push the aerodynamics to the absolute extreme to get more speed, which is like maximizing your storage utilization to 100%, you might accidentally block the airflow to the engine, and then the engine overheats and fails.
Oh, I see. So if my warehouse is 100% full, I literally cannot maneuver a forklift inside to pick the goods. So my throughput, my speed just completely fails.
Exactly. If you tune the car too far in one direction, it breaks. The overall service goals of a distribution network are a delicate balancing act. You are trying to achieve fast flow response and minimum inventories while simultaneously ensuring quality management and product lifecycle support.
And you just can't have it all.
You cannot maximize all of them at once. It's impossible.
So the true goal of a supply chain professional isn't to get a perfect 100% score on one specific KPI.
No, not at all. The goal is optimizing the trade-offs. You want to achieve a fast, reliable flow of goods with minimal operating variance.
Right, variance.
Yeah, operating variance reduction is crucial. A hospital can plan around a delivery that always takes exactly 5 days.
They know it's 5 days, they can schedule the rigging crew.
Exactly. But they cannot plan around a delivery that wildly swings between 2 days and 8 days. Predictability is often much more valuable than raw speed.
It's incredible how interconnected it all is. Okay, let's recap this journey for you, our listener. We started by exploring the strict 13 steps of a B2B order cycle.
Yeah, focusing on that critical strategy that happens in the order processing stage well before a single physical item actually moves.
Right. And then we looked at what happens when reality breaks those plans, which requires those predefined expediting contingencies to handle exceptions without panicking.
Exactly. And to handle those exceptions, we learned you need total visibility, moving way beyond just line-of-sight barcodes to satellite-linked RFID tags.
And by utilizing blockchain ledgers, all the different non-trusting parties in the supply chain can finally share an unchangeable, real-time, single source of truth.
Which is revolutionary. And finally, we unpacked how companies use a ruthless balancing act of KPIs weighing metrics like the cash-to-cash cycle against customer service availability just to ensure they're running a resilient, profitable business.
It really is a massively complex, invisible ecosystem just running quietly in the background of our lives.
It truly is.
And it leaves me with one final thought to mull over, something for you to think about long after this deep dive ends.
Let's hear it.
We've been talking strictly about business-to-business logistics today, where million-dollar MRI machines are tracked from the factory to the hospital. But as these technologies like satellite RFID and blockchain become incredibly granular and shockingly cheap to produce, will we eventually see a world where this B2B level tracking transparency becomes the standard for everyday consumers?
Oh, that's a wild thought.
Right. Imagine buying a complex electronic device, like, I don't know, a new laptop. You scan a QR code on the box, and instead of taking you to a marketing website, it shows you the exact real-time journey, the carbon footprint, and the exception history of every single microchip inside it, stretching all the way back to the raw materials.
Just total transparency.
Exactly. How would that level of radical, undeniable transparency change the way we value the things we buy?
That is a fascinating future to consider.
Until next time, keep diving deep.